For problem number 7, we're given a graph here, which we're told this is the graph of the derivative of f prime, and that this is for a continuous function f. So we're looking at a graph of the derivative, and we know that the function itself is continuous. So we need to keep that in mind for answering these questions. So for part A, we have where does f of x have critical numbers? So remember that a function has critical numbers wherever its derivative is 0 or undefined. Now, we don't have to worry about if any of those things are potentially not on the domain because we were told in the problem that f of x is continuous. So that tells us that f of x doesn't have any things not in its domain, and we can answer this question just by looking at the graph. So where f of x has critical numbers, again, where is its derivative 0 or undefined? Well, its derivative is 0 right here at x equals -5. Its derivative is 0 again right here at x equals 3. Its derivative is undefined at x equals 5 because we have a vertical asymptote there. And its derivative is 0 again here at x equals 7. So to answer that question, we just had where is this derivative graph, because remember we're looking at the derivative. Where is this graph 0 or undefined? It's 0 at 3 points and undefined at 1. So those would be our critical numbers up there. Part B asks, on what intervals is f increasing or decreasing? So remember that the function is increasing when its derivative is positive, and the function is decreasing when the derivative is negative. So let's do increasing first. So our function would be increasing wherever this graph is positive. So it's positive from negative infinity all the way up to -5 where it touches 0 for a moment, but it's positive up until that point to -5. It then is positive again from -5. It's positive all the way here to 3. After 3, it's negative, and then it's negative again, but it becomes positive again from 7 to infinity, the end of this graph. So those are the intervals where this graph is positive above the x-axis. So those 3 are where it's increasing. Decreasing then is obviously the opposite. When is this graph negative? When is it below the x-axis? Well, it's negative from 3 to 5 because it's negative down here. We can't really say it's negative at 5 because it's undefined. And then similarly, it's decreasing because our derivative is negative from 5 to 7. It's below the x-axis there too, so that's where it's decreasing. So those are our intervals of increase and decrease. And for part C, we're asked, where is f of x concave up or down? So where is it concave up? So concave up is when our second derivative is positive. So the easiest way, I think, to think about this is think about what did we know when the derivative is positive. When the first derivative is positive, that tells us that our function is increasing. Or when the first derivative is negative, that tells us that our actual function is decreasing. So you can think of it as the second derivative compares to the first derivative, just like the first derivative compares to the function. So if we want concave up, and we know that means the second derivative is positive, the second derivative is positive means the first derivative is increasing. So again, the first derivative being positive means our function is increasing. So therefore, that same thing has to apply one derivative step down. The second derivative is positive means the first derivative is increasing. So the reason we have to think of it like that is because we don't have a graph of the actual function to figure this out. So we want to know where the second derivative is positive to be concave, so our function is concave up, meaning we just need to look at this and say, where is this graph increasing? So this graph is increasing from -5 up to about 2. where it reaches a maximum here, because it starts decreasing again after that. So then it's decreasing this whole way, but then it's increasing again the rest of the graph after this horizontal, or after this vertical asymptote. So that's from 5 to infinity. So those are the points at where this graph is increasing. And then concave down, if we want our function to be concave down, that means our second derivative has to be negative. And if our second derivative is negative, that means our first derivative is decreasing. So decreasing is from negative infinity all the way up here till -5. We're also decreasing then again from, sorry, this should have been -2 here when I put it here the first time. From -2, this is decreasing up till this vertical asymptote. So we would go from -2 to 5. So this is our intervals of concave up and concave down, again, based on looking at that derivative graph. So then part D says sketch a possible graph of f of x. So this is going to be a little bit difficult because there's multiple answers to this, because this graph, we only know about the slope of the graph. We don't know any actual points, but we'll just graph something that's possible. So what we know is that at these critical numbers, -5, 3, 5, and 7, our function has some sort of horizontal or vertical tangent line. And at -5, at 3, and at 7, it's definitely a horizontal tangent line because our derivative is 0, which means slope of tangent line is 0. At 5, our derivative is undefined, so that means our slope is undefined. In other words, we have a vertical tangent line. We also have to obey these things that are showing us increasing and decreasing. And we also have to obey these concavity issues. So a good way to think about this is, let's just look at this in intervals. So the first thing that we're going to draw from the left is starting from -infinity. So from -infinity up to -5, it's increasing and concave down. So increasing concave down, for example, could look like this. So this is increasing, but it's concave down because the shape is like that. So at this point, we know we have a horizontal tangent line here. Let me make this a little bit more horizontal. We know we have a horizontal tangent line here because our derivative was 0. But we're increasing both there and after it. So we're then concave up until -2, and we're also increasing again. So we're going to be like that. So this was a horizontal tangent line right here. So we went horizontal for a second, and then we're back to increasing. At -2, we flip from being concave up to back to being concave down. And then we're increasing all the way to 3. So this is going to look like this here. We switch to concave down here. We're still increasing, and then at 3, let me draw a dotted line up here so I can get this accurate. At 3, now we have another horizontal tangent line. And this time, it in fact is a maximum, because at 3 we go from increasing to decreasing. So we know this is a max, and it goes back down. So here we have a vertical tangent line coming up at x equals 5. We know it's decreasing on both sides of it. It's decreasing up to 5, and it's decreasing after 5. So this is going to have to look something like this, where this is a vertical tangent line right here. And notice this fit with our concavity as well, because we were concave down until we hit the vertical tangent line, but then we're concave up after that. So this last interval, we're concave up now for the rest of the graph. We're decreasing until we get to 7. So let me draw that like this. And at 7 to infinity, we then increase forever, and we're still concave up. So here was a horizontal tangent line. So notice the main key points of this are intact. We have horizontal tangent lines here, here, and here, and that's because our derivatives were 0 at those points. We have a vertical tangent line here at x equals 5 because our derivative was undefined at that point. Our increasing and decreasing all match the intervals that we got, and so does our concave up and down. So keep in mind, the reason why this is sketch a possible graph and this isn't the exact graph is because I don't know where any of these y values are. As long as I had all this critical information, the horizontal tangent lines, the vertical tangent lines, where this graph was placed or how steep these lines were, you wouldn't be able to tell that really from the information given. So there's a lot of different ways that you could have drawn this and it's still been correct. But the important part is that you got these intervals to match with what's actually happening here.
The Teaching Center, UF's Learning Resource Center.